Start. Make sure the screen is visible to you and I'm audible to you. If it is so, please make yes in the chat box. Okay. So, hello, hi everyone. I welcome you all in this session of alternating current, and this would be the last. And in the previous session, we have talked about two combination circuit like LR circuit we have covered, and pure capacitive circuit also we have covered. And we have seen that what are the phasor diagrams and how the current lag or lead in different types of circuits. Now, this will be the final day of this alternating current chapter. Today also we will done some leftover and the PYQs that I have selected and LCR circuit. Okay, so this is the agenda for today class. Now, be attentive in this class because if no one has attended a single lecture of this alternating current, this LCR circuit covers the whole. It's a full recap of the entire chapter. So please do not miss it. Now, let's just get started with it. Now, in the previous session, we have talked about this LR circuit. Now, we applied the alternating current to RC circuit. Now, firstly, you need to understand what a RC circuit is. RC circuit is that circuit consists of a capacitor and a resistor itself. Okay. In LR circuit, if you have paid attention clearly, you have seen that in LR circuit, we have a device named inductor and resistance. Then we have seen the phase difference of them. Okay. Now here, if you see that resistance will make no change, voltage and current will be in same phase always. Okay. So as we saw in the previous lecture that LR circuit may the only role played by this inductor. So in this also in RC circuit also all the parameters, all the changes and lagging and leading of the current or voltage will be only applicable to this capacitor because we know that resistor is that device in which voltage and current remain in same phase. Okay. So first of all, we have decided that what is the current at that instant. So current at a particular instant is I is equals to I naught sine omega t. Now voltage across the capacitor at any instant. So you everyone know that voltage across a capacitor is nothing but Q is equals to CV. Q is equals to CV. We all know about this formula. Okay. So Q is equals to C into VC. VC is the voltage, alternating voltage that we have applied across the inductor. Now, VC is equals to Q by C. Clear? VC is equals to Q by C. From here, we have put it the value of Q in terms of I. How we can do that? Because we know that Q is nothing but I is nothing but dq by dt. Got it? So dq will become I into dt. Now, if I want to know the total charge, which is capital Q, I have to integrate this stuff. So Q is replaced by integration of I into dt. Got it? Clear? Now, huh. So we have put the value of Q in terms of I. So I key value we already know it is I naught sine omega t. When we put this value and integrate this structure, it will become I naught sine omega t minus pi by 2. Okay. How we have done it? It's a mathematical part. I'm not going to re-explain it again and again because we have done it in the LR circuits. Okay. So you put the value of I is equals to I naught sine omega t. I naught will be common, so it can be taken out. Then the only term remaining here is sine omega t dt. Integration of sine omega t will become cos omega t and that piece. Okay. So here the voltage is coming out as I node. देखो, integration of sine omega t will become cos omega t. But we want voltage and current in same trigonometric ratio. So here is also sine omega t. So we want this term to be in sine theta. So for that, we have made this change sine omega t minus pi by 2. And we know that sine omega t minus pi by 2 will be minus cos omega t. Clear? Now, voltage across at any instant across R is nothing but VR is equals to I node into R sine omega t, which can be easily derived. V is equals to IR. You put the value of I, which is I node sine omega t. So you will get the value of voltage across resistor, okay, which is I node R sine omega t. Now V is equals to nothing but VR plus VC. This is V. V is equals to VR plus VC. We can say that because energy is conserved. So whatever the potential, apply the Kirchhoff's law here. So the net algebraic sum of the voltage drop across a closed circuit will be always zero. So V is equals to VR plus VC. Now we put the value here. Again, this is a kind of equation that we have solved in the previous session. So finally, we have derived, we have come to this conclusion. We need to put, just a second. Here, omega C is nothing but, ओमेगा सी क्या है, सॉरी एक्स सी क्या है यहाँ पे, एक्स सी इज नथिंग बट देखो, इफ यू इंटीग्रेट दिस आई, it will become minus cos omega t by omega. So it is coming out as I naught divided by omega c. So this 1 upon omega c we have considered as xc, which is nothing but the capacitive reactance. ठीक है, तो यहाँ पे मैं लिख देता हूँ xc is nothing but 1 upon omega c, which is capacitive reactance. Capacitive reactance, the resistance offered by the capacitor in the circuit. Clear? This is capacitive reactance. Got it? Now, again, that particular thing for XC, you need to assume it at Z sin phi. For R, you need to assume it at Z cos phi. Z is nothing but square root of XC square plus R square. And tan phi is nothing but the ratio of XC upon R. From that equation, we can say that applied voltage is equals to I naught Z sin omega t minus phi. So we can say that here it is showing as minus phi, which means the voltage applied across a RC circuit is lagging with a phase difference of phi from the current, because current here is I is equals to I naught sine omega t on. And this particular thing, this voltage is minus phi, which means the voltage is lagging in this situation. And we also know in pure capacitive circuit, we have seen that voltage is lagging, current is leading, and resistance has no role, which means all the vital role or the main role is capacitor playing here. And capacitance may current will lead, voltage will lag. The same thing is happening here. So suppose this is the red color arrow is showing the current at that particular instant. This is the phasor diagram. This is nothing but phasor. You should know how to draw a phasor diagram. ठीक है, मैंने आपको बहुत बार बता दिया है. Now you will be familiar with this term, how to draw this phasor diagram. This is I. So omega t you have to measure from the positive axis. This particular axis, x-axis. So this is omega t, but this angle is omega t minus phi, which means it is less, phi less than omega t, which means this particular angle is nothing but phi. You have to decrease this phi value from omega t, then you draw the voltage phasor. Got it? So here also, what is the value of z? It is nothing but square root of x square plus r square. This phi here is nothing but the power factor. Okay? Always remember this phi is nothing but a power factor. Okay? Cos phi. Now this is xc upon this thing is nothing but impedance triangle. Told you. Impedance triangle. Okay? Now let's try to solve this question. This is RC and LR circuit given in the situation. If Z1 and Z2 are the impedance of the given circuit A and B as shown in figure, then choose the correct option. ठीक है, देखो यहाँ पे दो फिगर आपको given है, क्लियर है. So L की value is 5 millihenry, R is given as 10 ohm in this situation, and this is 6 volt. देखो यहाँ पे ये वाला जो सर्किट है, ये डीसी वोल्टेज पे, दिस इज वर्किंग ऑन डीसी. ठीक है, एंड इफ इट इज वर्किंग ऑन डीसी, ओमेगा विल बी जीरो हियर, देयर इज नो ओमेगा. ठीक है, फ्रीक्वेंसी का मतलब ही नहीं होता. ठीक है, बिकॉज डीसी इज अ कांस्टेंट करंट. नाउ हियर इन दिस सिचुएशन इफ यू विल सी, तो यहाँ जो मेनली जो इम्पिडेंस आएगा, अब देखो डीसी सोर्स है तो करंट भी क्या होगा, कांस्टेंट. अगर करंट कांस्टेंट है तो इसके अक्रॉस तो कुछ भी होना है नहीं, बिकॉज VL, which means voltage across the inductor, is only developed due to the change in current. And if this change in current is zero, there is no voltage across this. तो यहाँ इसके अक्रॉस वोल्टेज कितना हुआ, जीरो हो गया. क्लियर है, इसमें बात समझ में आई. इसके अक्रॉस वोल्टेज कितना हुआ, जीरो हो गया, विच मीन्स यहाँ से करंट इजीली पास कर जाएगा. करंट के लिए दिस विल बिहेव एज अ वायर, देयर इज नो पोटेंशियल डिफरेंस अक्रॉस इट, सेम पोटेंशियल पे. The only thing here in the circuit is 10 ohm resistor. Got it? इस बात में किसी को डाउट है? देखो, this is a DC source. DC source में current is constant always. If current is constant, the potential, the EMF induced in the inductor will be zero, because EMF induced in inductor is L di by dt. ठीक है, L di by dt. Okay. Now di by dt is zero. Di by dt is zero because current is not changing in inductor due to this DC source. So voltage across the inductor will be zero. If voltage across, देखो ये मेरे पास अगर एक वायर है, इसके यहाँ भी तो इन दोनों पॉइंट्स पे भी तो वोल्टेज की वैल्यू क्या है, जीरो है. ठीक है, क्लियर. करंट जीरो नहीं, वोल्टेज जीरो. पोटेंशियल डिफरेंस किससे आएगा, जब लॉस होगा कुछ या गेन होगा. लॉस और गेन हो ही नहीं रहा है, तो इट विल बिहेव एज अ सिंगल वायर. तो यहाँ पे जो Z1 है वो सीधा सीधा क्या है, रेसिस्टर ओनली, रेसिस्टेंस विच इज 10 ओम. देन यहाँ पे अगर बात करें, ये एसी सोर्स है, यहाँ पे करंट चेंज कर रहा है, विच मीन्स यहाँ पे वोल्टेज आएगी। और यहाँ पे जो जेड होगा विच इज नथिंग बट स्क्वायर रूट ऑफ एक्स सी स्क्वायर प्लस आर स्क्वायर। अब एक्स सी क्या क्या मतलब है भाई, एक्स सी इज नथिंग बट वन अपॉन ओमेगा सी। एक्स सी की वैल्यू पुट करो, वन अपॉन टू पाई एफ इंटू सी इंटू ओमेगा की वैल्यू इज टू पाई एफ इंटू सी। नाउ वन अपॉन टू पाई एफ की वैल्यू क्या है, टेन रेज टू द पावर थ्री डिवाइडेड बाई पाई इंटू कैपेसिटेंस इज गिवन एज टेन, सॉरी, दिस इज द कैपेसिटेंस। चलो मैंने यहाँ पे पुट कर दिया कैपेसिटेंस, फ्रीक्वेंसी इज 50 हर्ट्स ओनली, दिस इज 50। तो ये कैंसिल हो गया, पाई से पाई कैंसिल हो गया, सो इट इज बिकम एज वन अपॉन टू 50 इंटू टेन रेज टू द पावर थ्री मल्टीप्लाई बाई, ये माइक्रो फेरेड में है तो फेरेड में कन्वर्ट करने के लिए -6 माइक्रो में। देन दिस विल बिकम, देखो टू फाइव जा 10 विच इज 100, 100 is also 10 raised to the power 2, 3 will become 10 raised to the power 5, it will become 1 upon 10 raised to the power minus 1 which is 10। सो XC की वैल्यू आ गई है 10 ओम, ठीक है, यहाँ पे क्या आ गया है 10 ओम, प्लस ऑलरेडी R भी है वैस, तो दिस विल बिकम 10 ओम स्क्वायर प्लस 10 ओम स्क्वायर, सो इट इज रूट 2 टाइम्स 10, 10 रूट 2। क्लियर? तो वी कैन से इट क्लियरली, देखो Z1 इक्वल्स टू Z2 तो हो गई, ये भी नहीं आ रहा है। Z1 इज लेस देन Z2, Z1 यहाँ पे कितना था, सिर्फ 10 था, और यहाँ पे Z1 इफ यू पुट द वैल्यू ऑफ रूट टू ऑल्सो इट इज 1.414 विच इज 14.414 ओम। 14.14 ohm means this value is greater, means Z2 is greater than Z1, so option A is the correct option। है ना इंटरेस्टिंग? now this one, very good question, try to solve it। a capacitor of reactance 4 root 3 ohm, capacitor of reactance which means directly value जो given है that value is xc, xc is given as 4 root 3 ohm and a resistance 4 ohm which means R is given as 4 ohm, okay, are connected in series with an AC of source of peak value of voltage as, which means the V node is given as 8 root 2। मैंने पहले भी आपको बताया, to solve any competitive exam question firstly write what is given to you, ठीक है, then you have to apply the formula। देखो यहाँ पे power dissipation in the circuit पूछा, power dissipation in the circuit is nothing but IRMS if it is what, if it is a AC circuit, IRMS into VRMS into cos phi। फाई की वैल्यू कहां से आएगी, आरसी सर्किट है, दिस इज ए आरसी सर्किट विच इज गिवन इन द क्वेश्चन, ये ऑल्टरनेटिंग सोर्स ऑफ करंट है, गॉट इट। और आरसी सर्किट में फेज डिफरेंस कहां से आएगा, तो वी कैन इजीली कैलकुलेट इट, tan phi इज इक्वल्स टू एक्सी अपॉन आर, एक्सी की वैल्यू भी आपको गिवन है विच इज व्हाट, 4 रूट 3 and r is given as 4 so it will become root 3 which is phi is nothing but 60 degree, tan 60 is root 3। क्लियर है? अब देखो, वी नो, वी वांट टू नो द आईआरएमएस एंड वीआरएमएस, देखो कैन वी रिप्लेस आईआरएमएस ताकि मुझे आईआरएमएस की वैल्यू ना निकालनी पड़े। आईआरएमएस को मैं लिख सकता हूँ वी आर एम एस अपॉन जेड, कैन वी राइट दिस बिकॉज दिस इज द ओम्स फॉर्मूला, वी कैन अप्लाई दैट। सो पावर हियर विल बिकम वी आर एम एस स्क्वायर अपॉन जेड इंटू cos phi। Now put the value. Now we know the value of V naught. We have to calculate the VRMS. VRMS is nothing but root 2 times V naught by root 2. We all know that. V naught is given as 8 root 2, so it will become 8 volt. VRMS is 8 square divided by Z is nothing but you have to square root of that. Z is equals to square root of XC square plus R square. XC की वैल्यू कितनी है बताओ? XC is 4 √3 and R is 4. So it will become 16 into 3 plus 16. So it will become 4 into 2, which is 8. 16 3 is a 48 plus 16 is 64. And ultimately you can see you can take 16 common. So 3 plus 1 is also 4. 16 into 4, 4 into 2. Okay, this is also 8 ohm. So it is 8. Cos 5 will become cos 60, which is 1 by 2. This will cancel. 2 2 is 2 4 is 8. So power here is 4 watt. So 4 watt is the answer of this question. Okay. And this is the latest question of JEE main. So these types of question you can expect from this. Only formula wise question. Formula. If you know the formula of 10 phi, how to calculate this power factor, that you can also take. Okay. And one more thing, that cos phi, if you will calculate in this circuit according to impedance triangle, so cos phi will become R upon, sorry, R upon Z. ठीक है, clear है? So cos phi is the power factor of any AC circuit, which tells you about that how much power is consumed in that particular circuit. ठीक है? If you see that for a pure resistive circuit, cos phi is 0. Phi की वैल्यू क्या होती है उसके लिए? फेज डिफरेंस इज 0, बिकॉज रेसिस्टेंस में वोल्टेज और जो करंट होता है दोनों सेम फेज में होते हैं, तो उनकी जो फाई की जो वैल्यू होगी वो क्या होगी? 0. cos 0 is 1, which means totally power जो कंज्यूम होगी वो रेसिस्टेंस में होगी. That is also good. Pure capacitive circuit में if you will see, the phase difference is 90 degree. I have seen. We have solved it. Phase difference is coming out as 90 degree because voltage lead the current in inductive circuit. Voltage lead the current by 90 degree. So phase difference become 90. Cos 90 is 0, which means power consumed in a full cycle by a inductive circuit will be 0, and we have discussed in the previous session. So that is why this cos phi is the power factor which tells you about the power consumption in any AC circuit. Okay, chalo, let's try to solve this question. When a coil is connected across a 20 volt DC supply, it draws a current of 5 ampere. When it is connected across 20 volt 50 hertz AC supply, it draws a current of 4 ampere. The self inductance of the coil is. Chalo. So try to solve this question. Meanwhile, I am discussing the next concept. ठीक है? Then we will come back to this question and solve. Okay. यहाँ पे एक coil है which is connected across a 20 volt DC supply. तो करंट कितना ड्रॉ कर रहा है? 5 एम्पियर. व्हेन इट इज कनेक्टेड अक्रॉस अ 20 वोल्ट 50 हर्ट्ज एसी सप्लाई, इट ड्रॉज अ करंट ऑफ 4 एम्पियर. द सेल्फ इंडक्टेंस ऑफ द कॉइल इज, दैट यू हैव टू कैलकुलेट. गॉट इट? चलो नाउ एलसीआर सर्किट के बारे में बात करते हैं. तो एलसीआर सर्किट इज नथिंग बट द कॉम्बिनेशन ऑफ एल, सी एंड आर, which is an inductor, capacitor and resistor. So it is a combination of, it is a combination of resistor, inductor and capacitor. Got it? There are two types of this circuit. LCR circuit भी दो तरह का होता है. Series LCR circuit, and the next one is parallel LCR circuit. पैरेलल एलसीआर सर्किट. देखो, parallel LCR circuit previously was in your syllabus. If you talk about the syllabus before corona, so it is in the included in the syllabus of alternating current, but now it is excluded from the syllabus, so you don't need to study this. Only this portion of LCR circuit you need to study. Got it? Again, what we are going to do here, देखो E आपको given है, and we will not assume as E, we will assume as V. V is equals to V naught sine omega t. Now, the only difference play here will be the current. The current move across inductor, it will lag or lead. Current move across capacitor, it will lag and lead. Okay. We know that by the analysis of pure inductive circuit, pure capacitive circuit, that when currents move in a pure inductive circuit, it will lead. Okay. In pure inductive circuit, current will lead. In pure capacitive circuit, current will lag. Okay. So we only focus on the value of current. तो सपोज यहाँ पे हम क्या कर सकते हैं, लेट अस कंसिडर द करंट थ्रू द सर्किट, करंट इन एलसीआर सर्किट इज आई, बट दिस वैल्यू विल बी चेंज. देखो, करंट जो एल में फ्लो करेगा वही सी में जाएगा, एंड वही आर में, बिकॉज दिस इज अ सीरीज सर्किट. ठीक है. then we can say in series voltage will differ. This is the voltage across the inductor, which is, let's say, VL. Voltage across the capacitor, let's say, VC, and voltage across the resistor will be VR. Got it? Now, initially VL will become L di by dt, and let us assume the I is nothing but I naught sine omega t. Got it? Initially, both voltage and current in same phase. This is the total applied voltage. चलो इसे भी खत्म ही करते हैं. ठीक है ना? We only talk about the current. Clear? Now, from this equation, you can say L di by dt will become d by dt I naught sine omega t, and it will become I naught xl sine omega, sorry, cos omega t. This is equation 1. इसमें किसी को डाउट है? बिकॉज डिफरेंशिएशन ऑफ साइन ओमेगा टी विल बिकम कोस ओमेगा टी, एंड ओमेगा एक्स्ट्रा टर्म ओमेगा इनटू एल बिकम एक्सएल, which is the inductive reactance. Now, voltage across voltage across So from this concept, you can see that VC is VC is equals to I node XC sin omega t minus pi by 2. ठीक है, सेम ही डेरिवेशन है, सो बार बार से डिराइव नहीं करेंगे. ठीक है. सो हियर it is like just a second. It will be I naught xc sine omega t minus pi by 2. This is equation number 2. So only the difference here is that VR, voltage voltage across a resistor is given by VR is equals to I into R. I की value is I node R, so it will be I node R sine omega t. This is equation number 3. Got it? So you know the value of voltage across these three devices that we have: inductor, capacitor, and reactance. Now the total voltage we know according to Kirchhoff's law. Applied voltage, applied voltage is equals to VR plus VL plus VC by the conservation of energy also, or by the Kirchhoff's law also. Now, if we put the value here, you will have V is equals to I naught R sine omega t plus I naught XC, I naught XL sine omega t plus pi by 2, because in this current will lead. ठीक है, यहाँ पे cos ओमेगा टी को भी लिख सकते हैं ना, sin ओमेगा टी डायरेक्टली, sin ओमेगा टी प्लस पाई बाई, है ना, ये प्लस आई नोड एक्स सी sin omega t minus pi by 2. Got it? Now again here the voltage will become I node R sin omega t plus I node, you can take common, it will become XL cos omega t minus XC. This is also cos omega t. Clear? Now from here I node R sin omega t become I node XL minus XC cos omega t. Now, based on the value of this XL and XC, we will derive that finally current or voltage will lead or lag. Let's just understand this. Just give me a moment. Huh? So we have come to this conclusion that V is equals to I node R sin omega t plus XL minus XC cos omega t. Clear? Now you can assume this as Z1, R is as Z1, and this as Z2. Okay? Clear? Now, if यहाँ से situation बदलेगी, because suppose if XL is greater than XC, then the circuit will behave as a purely inductive circuit. Got it? The circuit will become inductive circuit because XL is greater. Give me a moment, huh? Just a second. ठीक है। सो गाइस अगर एक्सेल की वैल्यू ज्यादा हुई, ठीक है, एक्सेल की वैल्यू अगर ज्यादा हो गई सर्किट में, देन द सर्किट विल बिहेव एज प्योरली इंडक्टिव सर्किट। बट इफ इन केस एक्सी की वैल्यू ज्यादा हो गई, ठीक है, एक्सी की वैल्यू ज्यादा हो गई, देन वी कैन से जो टोटल जो वोल्टेज है अक्रॉस द रेसिस्टर विल बी प्योर कैपेसिटी, ठीक है। सो इट इज बेस्ड ऑन द assumption here that we have to made. हाँ, now v is equals to this one, we can say, okay, v is equals to, which is vr plus vl minus vc. So whichever is greater, that will decide that how the circuit will be. If xl, if xl is greater than xc, then in this case we will only have, so the resultant voltage here is given by r square plus, sorry, v square plus vl minus vc whole square. ठीक है, this is the resultant voltage formula. And if you talk about the current, it will be square root of this v square plus vl minus vc whole square divided by z. और z भी कैसे हम डिनोट करेंगे यहाँ पे, z is also given by square root of r square plus modulus of xl minus xc whole square. So suppose xl is greater than xc, then z will behave as a purely inductive circuit. If xc is greater than xl, then circuit will behave as a purely capacitive circuit. Got it? Now, if I draw the phasor diagram here, phasor diagram. Now, suppose these are the two lines. Two lines you have to make perpendicular to each other. Now let's say this is VR, because VR and IR will be in same phase, so VR को हम reference phase मान के चलते, ठीक है। The voltage in inductance will be lagging by 90 degree, we know that, ठीक है। तो इंडक्टर में क्या करती है, वोल्टेज लैग करती है, क्लियर। लेट मी जस्ट क्लैरिफाई दिस स्टेटमेंट। हाँ, तो ये थोड़ा उल्टा हो गया। यहाँ पे जो वोल्टेज है, जो कि वोल्टेज अक्रॉस द इंडक्टर है, will lead by 90 degree. We know that in LR circuit voltage lead 90 degree, so this will be represent this will represents VL by 90 degree. This angle will rotate 90 degree, but VC will be given by this line because it is lagging behind of 90 degree, ठीक है। Now based on the Z, value of Z, if XL is greater than XL, let me draw it on another page. So here we have, बहुत इजी है ये अंडरस्टैंड करने के लिए। देखो ये हमारा वी आर है, ये अपना वी एल है, एंड दिस इज वी सी। यहाँ पे एक प्री डिटरमिन्ड वैल्यू नहीं है, जैसे एल आर सर्किट में आपको वी अप्लाइड डायरेक्टली मिल रहा था बाय सॉल्विंग द इक्वेशन। यहाँ पे वो प्री डिटरमिन्ड वैल्यू है ही नहीं, बिकॉज वी हैव टू फर्स्टली हैव टू डिसाइड दैट विच वन इज लीडिंग, ठीक है, और विच वन इज लैगिंग। either this circuit is behaving as an inductive circuit or this circuit is behaving as a capacitive circuit, and that we can only determine by seeing the data in the question. क्लियर? तो दिस इज वीएल, दिस इज वीसी। फॉर फर्स्ट केस इसी में ही बता दे रहा हूँ, इफ वीएल इज ग्रेटर देन वीसी विच मीन सर्किट इज इंडक्टिव सर्किट, तो जो इनका रिजल्टेंट आएगा, इन दोनों का रिजल्टेंट, ये दोनों वेक्टर ही तो हैं, इन दोनों का रिजल्टेंट क्या होगा, इस डायरेक्शन में आएगा। ठीक है, इफ VL माइनस VC इज पॉजिटिव तो रिजल्टेंट होगा इस डायरेक्शन में, दिस इज, लेट्स से दिस रिप्रेजेंट्स VL माइनस VC। देन इन दोनों को ज्वाइन करेंगे, ये वाली जो लाइन है, देखो इम्पिडेंस की तरह ही आ रहा है ना ये, ठीक है। तो रिजल्टेंट विल बी ड्रॉन इन बिटवीन VL माइनस VC एंड VR, दिस एंगल वुड बी 5। ठीक है। नाउ इफ VL is less than VC, then what we can say? This is VR reference, this is VL, and this is VC. But the net resultant will come in the downward direction because VC is greater in the values. So VL minus VC, और ये मॉडुलस होता है, हमेशा याद रखना, this is the modulus. So only positive value will be taken. So this will come in downside. तो यहाँ पे हम क्या कह सकते हैं, ये will, this will be like this. ये से आप करंट और करंट से भी आप क्या कर सकते हैं, करंट से भी कंपेयर कर सकते हो, तो दिस विल बी 5। ठीक है, यू कैन टेक द रेफरेंस एक्सिस एज करंट एक्सिस एंड दीज आर द वोल्टेजेस, दैट आल्सो यू कैन सी। नाउ हियर इज द इंटरेस्टिंग phenomena that would come around is about if Z is minimum, if Z is minimum, अब Z मिनिमम कब होगा, Z is given by square root of R square plus XL minus XC whole square। अब Z मिनिमम कब होगा, either this value will become zero if XL is equals to XC, then only the Z will be minimum। ठीक है, put the value, and what is the minimum value of Z, it is R only। This is the state of resonance। Now the circuit is in resonance state। resonance state क्या है, when the natural frequency of the circuit, of the AC circuit will become equal to the frequency of applied voltage, then the circuit is said to be in resonating state। अब इसका मतलब क्या हुआ, रेजोनेटिंग स्टेट में जब Z मेरा मिनिमम है, विच मींस मिनिमम इम्पीडेंस मुझे मिल रहा है, इन द केस ऑफ मिनिमम इम्पीडेंस the circuit will draw the maximum value of current, so that is the meaning of resonating frequency। जब भी सर्किट रेजोनेटिंग स्टेट में होगा, the current flowing through the circuit will be maximum, otherwise जो भी दूसरे करंट होंगे उससे कम ही होंगे। ठीक है, क्लियर है? अब ये रेजोनेटिंग फ्रीक्वेंसी होती कितनी, तो फॉर दैट एक्सएल इज इक्वल टू एक्ससी। देखो ये कंडीशन है फॉर सर्किट टू बी रेजोनेटिंग, एक तो ये है, एंड VL इज इक्वल टू VC। ठीक है, ये भी, xc is given by 1 upon omega c is equals to 1 up omega into L. Then we can say omega square is equals to 1 upon LC. Omega resonating here is 1 upon root LC. So this is the resonating frequency. And it can also, this is the angular resonating frequency. If we want the linear frequency, it would be 1 upon 2 pi square root of LC. Okay, so these are the two frequencies. Clear? In this state, we can say circuit will be in the maximum state. Clear? Now, I just need to draw some graphs also. Only one graph I'll show you, and then we'll end up this lecture and this chapter also. Okay. So the graph will be drawn between Z and F. This is Z and this is F. So the variation is like this. Okay. At this particular state, having a minimum value which is Z minimum. और ये कब आती है? जब फ्रीक्वेंसी विल बी रेजोनेटिंग फ्रीक्वेंसी. अदरवाइज हमें यहाँ पे हमेशा एक दो अलग अलग फ्रीक्वेंसी के लिए सेम जेड की वैल्यू भी पॉसिबल है. दिस इज Z1 एंड दिस इज Z2. इन्हें ही जब हम बोलते हैं, ये जो सॉरी दिस इज नॉट Z1, दिस इज F1 एंड F2. इन्हें ही हम क्या बोलते हैं? दिस गैप इज टर्म्ड एज द बैंड विड्थ. बैंड विड्थ. Got it? So remember this graph. You can draw the same for V and I with respect to this resistance also. Clear? So this is it for today's class, and this is it for this chapter. I hope you understood all the basic and whatever the concept is taught in this lesson, and make the most out of it. If anyone has any kind of doubt in this chapter, let me know in the chat box. Otherwise, the lecture is being over. Thank you so much for being attentive and being responsive in the lecture. Okay. Bye bye. Take care of yourself.